function. Okay, the name is set by me. So we call our algorithm, I mean minimum function, for the first part to find its minimum, and then call the function recursively for the second part to find its minimum. The minimum of first part, suppose the minimum of first part is stored in variable m1, and the minimum of the second part is stored in variable m2. Okay, so we have function minimum function. It's a name. We call here recursively the function for the first part, then recursively for the second part, and store the solutions into variable m1 and m2. So m1 is the minimum of the first part, m2 is the minimum of the second part. So in the third step, we should find the minimum of the total array. What's the minimum of the total array? How we can compute it from m1 and m2? It's enough to compare m1 and m2, any of them which is smaller, any of them which is minimum between these two values is the minimum of, or it is the minimum of the total array, is the minimum of the original array. So we compute minimum of m1 and m2, and this is the third step of our approach. If we put all of these things together, we get this code. The name of our algorithm is minimum function. The input is array A, the first index is I, the last index is J. The first step of our algorithm is dividing the array into two parts. So we compute the middle index. The middle index it can be obtained by adding index, by adding first index and the last index, I mean I plus J, then dividing it by 2. I plus J divided by 2 may not be integer, so we take its floor to make it integer. So the first part will be from I to Q, and the second part is from Q plus 1 to J. Okay, if I draw the picture from I to Q and from Q plus 1 to J. So the second step, in the second step, we call recursively our function for the first part and recursively for the second part. We store the answer of the first part in M1 and the answer of the second part in M2, and then in the third step we compute the minimum of M1 and M2 and return the minimum of these two values as the total solution, as the minimum of the input array, of the minimum of the original array. Then we put a stop condition because our algorithm is recursively. At first, we have an array of n numbers. Then it is divided into two parts. Each part has n divided by 2 numbers. Then each part is solved recursively. So that part is also divided into 2 parts. So we have arrays of n divided by 4 let me draw. At first, we divide an array of n numbers into two parts. Each part has n divided by 2 arrays. Then recursively, this array is divided more. From index 1 to index n divided by 4, and from index n divided by 4 plus 1 to end of. And the second part is also divided into 2 smaller parts. And this division continues finally. We will reach to problems that has only one number. So it is not needed to divide the array more. This is the stop condition, okay? So in the first line of the algorithm, we write the stop condition. The stop condition is here that we have only one number in the array, and when the first index and the last index becomes equal. So I put the stop condition in the first line of the algorithm. If I is less than or equal to j, then we return the only number of the array as the solution, and we do not continue, and we do not do recursive calls anymore. Okay, any question? Okay. Your friend asks me explain page 40 of the book. Let me open the book. Okay. Let me share my screen.
We are C.
Okay. The page number 40. Okay. This is the page number 40. Okay. Now, you ask me that explain this page. I explained this page in the following because it's about the merge sort that I am going to talk about it in the following. Okay, so please. Okay, I can explain the second example on this one. The second example is that we are going to sort a given array. Okay, we are given an array of some numbers. For example, here we have 8 numbers in an array. The first number is 12, then 3, 7, 9, 14, 6, 11, and 2. We are going to sort. So the problem is sorting. We are going to sort. Okay. And we are going to design an algorithm for sorting using divide and conquer approach. Okay. The first step is dividing the problem into some smaller subproblems. Again, here we divide the problem into 2 equal size subproblems. So if we have 8 numbers in the array, then we divide it into 2 parts. The first part has 4 numbers, and the second part again 4 numbers. The first part is from index 1 to 4, and the second part from index 5 to 8. Okay. Let me explain the algorithm at first, then we are going to this picture, and I am going to explain the example. Okay, so please let me back to our slides. The example 2. So example 2, sorting an array. We have an array of n numbers, and we are going to sort the numbers in an increasing order. The first step of the approach is dividing the problem into some smaller subproblems. Here again, we divide the problem into 2 equal size subproblems. The first subproblem has n divided by 2 numbers from index 1 to index n divided by 2. The second part from index n divided by 2 plus 1 to index n. Okay. This is the first part and the second part. Okay, this is the first step. So in the first step, again, we compute an index, which is the middle index. Okay, if I here is 1 and j here is n. This is the first step. Then in the second step, we call our algorithm for each of the subproblems. The second step. Let we call our algorithm by merge sort. I named it merge sort. Suppose the name of our algorithm is merge sort. So we call our algorithm recursively for the first and the second part. For array A from index I to index Q. Then recursively we call the algorithm for index Q plus 1 to index J. This is the second step of our algorithm. What about the last step, the third step? In this step, we should combine the solution in this step. We combine the solution. We combine the solutions of the sub problems. In the second step, we recursively called merge sort for the first part and merge sort for the second part. So after the step 2, after the second step, the first part is sorted and the second part is also sorted. For example, we may have something like this. In this example, part 1 is sorted, part 2 is also sorted, but if we see the total array, it is not sorted. While the first part is sorted and the second part is sorted, the total array is not sorted. So in the third step, we should combine the solutions of the first step and the second step and compute the total solution. I mean, the first part is sorted, the second part is sorted, but the total array is not sorted. We should rearrange the numbers in the array and make the whole array sorted. The total array should be sorted. So in the third step, we should do this. In the third step, we should combine the solutions of the sub-problems and make a solution for the total problem. But how we can combine these two parts? We put a name for the algorithm that combine the two parts. We name it merge. Merge is an algorithm that we should present to combine the two parts, the two sorted parts, and its output is sorting of the total array. A sorted total array is its input, is output. So merge gives the two parts and combine them. So we get as input to merge algorithm array A, first index, middle index, and the last index. And this algorithm should combine the two parts. But how we can combine the two parts? It needs some explanation. Please let me come back, go back to this slide.
How we can merge, Doctor? Can we
Okay, I'm going to explain. Yes, I'm going to explain.
How?
Suppose the first part is sorted and have the numbers 5, 10, 15, and 25. The second part is also sorted 1, 6, 20, and 3. How we can combine these two parts? To combine these two parts, we let me give these examples in the next slide. Let me go to the next slides and describe how we can merge. I write again the array, which its two parts are sorted. 1, 2, 3, 4, 5, 6, 7, 8. That 5, 10, 15, 25, 1, 6, 23. Okay, to combine, we use two auxiliary arrays, array L and array R. We copy the content of the first part to array L, and we copy the content of the second part into array R. So so we have in array L 5, 10, 15, 25, and we put infinity as the last number in L. Then we copy the content of the second part in array R, 1, 6, 20, 30, and again we put infinity as the last number in R. We define index I and index j. Index I is 1 at first, index j is 1 at first. Index I is used for indexing into L, and index j is used for indexing into R. Then we are going to sort array A in total, okay? 1, 2, 3, 4, 5, 6, 7, 8. we use another index K for array A, which is initialized to 1. The minimum number of array L is in the first room. So 5 in array L is the minimum of array L, is the minimum number of array L. The minimum number of array R is in the first room, which is 1. Okay. If we compare the minimum of L and the minimum of R and find the minimum of these two values, that will be the minimum of the total array. Okay, because 5 is the minimum of L and 1 is the minimum of R. The minimum of these two values is the minimum of the total array, is the minimum of array of the original array. Okay, so we compare these two values. Any of them which is minimum is copied in the original array A. So 1 is copied to the first room of array A, and because value 1 is copied from array R, the index of array R is increased. So J is increased by 1 and no J is 2. And also the index of array A is increased. Then we again compare the room of L of index I and the room in array R of index J. So at this step we compare 5 and 6. In the previous step we compared 5 and 1. 1 is minimum. 1 is copied to the array and the index of it is increased. Then we compare 5 and 6. Any of them that is minimum is copied to the array A and its index is increased. Here between 5 and 6, 5 is minimum, so 5 is copied to array and its index is increased by 1. So I is increased by 1, I is now 2. Then we compare, also the index K is increased 1. Then we compare 10 and 6. 10 and 6. 6 is minimum, so 6 is copied and index K is increased. And also index J is increased because 6 is minimum and 6 is copied to A and its index is increased. Then we compare 10 and 20. Any of them that is minimum is copied to array and its index is increased. So 10 is copied to array A and its index is increased. Then we compare 15 and 20. Any of them that is minimum is copied to array A. Here 15 is minimum, so 15 is copied to array. The index of K is increased. The index of I is also increased. Okay. Then we compare the room of L whose index is I and the room of R whose index is J. Here, so I mean here we compare 25 and 20. any of them which is minimum is copied. Here 20 is minimum, so 20 is copied to A, and index of A is increased, and also index of J is increased because the index of the minimum is increased. 20 was minimum, so its index is increased. Now we compare 25 and 30. 25 is minimum, so 25 is copied, its index is increased, and the index of I is also increased. Now we compare infinity and 30. 30 is minimum, so 30 is copied, index K is increased, and index J is also increased. At last, index I is the index of the infinity in L, and index J is the index of infinity in R, and all of the elements of L and R are copied into A. Because in each step we copy the minimum one between the elements of L and R, so the numbers and the elements of L and R are copied into A from minimum to maximum, and they are in a sorted order. Here we have 1, 5, 6, 10, 15, 20, 25, and 13, which is the sorted order of the original number. And in this manner, two parts are merged, two parts are combined. But by this method, we combine the part 1, which is sorted, and part 2, which is sorted, and we get an array that is sorted in total. Okay, this is the approach that by it we combine two sorted parts. This is the merge. This is called merge. Merge is our method for combining solutions of two subproblems. The first part is sorted, the second part is sorted, and merge combine these sorted parts into one total sorted. Okay. Now let's come back and let's go back to the page number 14. Okay, do you see the page 40?
Yes, Doctor.
Okay. Here you see the input array has 8 numbers: 12, 3, 7, 9, 46, 11, and 2. In the first step, we divide the array into two parts. The first part has 4 numbers, and the second part 4 numbers. Okay. Because we call in the second step we call or merge sort algorithm recursively for each part. So merge sort is called for the first part. The first part is an array of four numbers. The numbers are 12, 3, 7, and 9. Merge sort is called for this array. You can imagine that merge sort is called on an input array of 4 numbers. Suppose you have an array of 4 numbers and merge sort is called for it. What happens? Again, because we call our algorithm recursively, again for this array, algorithm is called, and in the first step of the algorithm, this array is divided into 2 parts. So the array is divided into 2 parts. Each of them has 2 numbers. The first part has number 12 and 3. The second part has number 7 and 9. Again, in the second step of algorithm, we call merge sort recursively for each part. So merge sort is called for this part that has 2 numbers. If we call merge sort on this part, because it is called recursively, again in this function call, again the first step of algorithm is done. So again the array is divided into 2 parts. So we have 2 elements. This is divided into 2 parts. Each part has only 1 element. The first part has number 12. The second part has number 3. At this step, a stop condition is satisfied because we have only 1 number, and the first index and the last index of the algorithm becomes equal. So we do not further divide the input array. So we just return 12 as the result of sorting. Okay. Then we, in the second part that has number 3, the function return 3 as the result of sorting. Okay. So the function call for the array that has only element that has only 12 number, just return 12, and the second call for the second part returns 3. Now, in the third step of that function call, we merge these 2 parts. We have 2 parts: a sorted part that has only 12. The second sorted part has only 3. We use merge as I described in the slides. We merge these 2 parts. We copy 12 in L, we copy 3 in R, and give 2 index I and J, and copy the minimum in the result first, and increase its index. Then 12 is compared with infinity, and 12 is minimum. Between infinity and 12 is minimum. So 12 is copied, and the index of it is increased and go to infinity, and the merging of these 2 parts is finished, and we have a merge. We have the result is merging of 12 and 3, which is 3 and 12, which is sorted. Okay. For the second part also, this is repeated. This is repeated for the second part. In the second part, we have 7 and 9. It was divided into 7 and 9. 7 has only one number, so it is returned as the sorted array. 9 is only one number, so it is sorted and it is returned as the sorted array. Then we merge 7 and 9. The result is 7, 9, which is sorted. Now we have a two-part, which is sorted 3, 12. The second part is sorted 7, 9, and we should merge these two parts. Again, we use merge algorithm as I described. An array L and R and two arrays L and R are considered. The first part is copied to L, the second part is copied to R, and to end is I and J. And as I described in the merge, these two parts are merged, 3, 12, 7, and 9. Because 3 is less than 7, 3 is copied. Its index is increased. Then between 12 and 7, 7 is minimum, so 7 is copied, and its index is increased. Then between 12 and 9, 9 is minimum, 9 is copied, as index go to infinity. Between infinity and 12, 12 is minimum, so 12 is copied. Okay, for the other part, this scenario is repeated. In the second part, in the right side, we have an array of 4 elements. It is divided into two elements array. Each of two elements array is divided into one element. Then we reach to a stop condition. Stop condition is satisfied. Then we stop here and return back from recursive calls. So the third step of merge sort is done, and 14 and 6 is combined and is merged. The result of merging 14 and 6 is 6, 14. Also for the other part, merge sort of 11 and 2 is 2, 11. Then these two sorted parts are merged. Merging of 6, 40 and 2, 11. Between 6 and 2, the minimum one is copied and its index is increased and go to 11. Between 6 and 11, 6 is minimum, so 6 is copied and its index goes forward. Between 14 and 11, 11 is minimum, 11 is copied and its index go to infinity. Infinity and 14, 14 is minimum, so 14 is copied. And finally, we have two parts of each of them has 4 elements, 4 numbers, and we should merge them. We have 3, 7, 9, 11, 2, 6, 3, 7, 9, 12, 2, 6, 11, 14. We should merge these two parts. Between 3 and 2, 2 is minimum, 2 is copied and its index is increased. Between 6 and 3, 3 is minimum, 3 is copied, its index goes forward. Between 7 and 6, 6 is minimum, so 6 is copied and its index go forward to 11. between 11 and 7, 7 is minimum. So 7 is copied at its index go to 9. Between 9 and 11, 9 is minimum. So 9 is copied and its index go to 12. Between 12 and 11, 11 is minimum. 11 is copied and its index go to 14. Between 14 and 12, 12 is minimum and is copied in the destination and its index go to infinity. Between infinity and 40, 14 is minimum, so 14 is copied and its index go to infinity and the algorithm finishes. Because divide and conquer approach use recursive calls, it's understanding what happens is a bit complicated. We should know how recursive calls work. Okay, I can explain.
Doctor, please, the numbers on the pointers of each step. What does mean, please? Numbers on pointers in each step.
Okay. I say. Let me see, what does it mean? 1, 2, 3, 4. 1, 2, 3, 4, 5. 9. The number.
This is the number
okay.
of
Yes, I know. The number on the arrows, the number of arrows show the order in which the function is called. Okay. First, we call merge sort for the first part. The first part has 4 elements, 4 numbers. So this is the first function call. Then this 4-element array is divided into 2 parts, and the second function call is for these 2 elements array. Okay. Then this 2-element array is divided into 2 parts. Each of them has 1 element, and we have a function called for 12. The third function call is for 12. The fourth function call is for 3. Then we return back from this function call and merge the result. 5 here on these 2 array. These 2 arrows show merging in the first in the fifth in the 5 step. We merge these 2 and get an array of 2 elements, 3 and 12. Then the next function call is here. The 6 function call is the function call of merge source for this part. So these numbers show the order of function calls. Okay. I can draw in our slides. Let me draw in our slides. In this slide, show you how function calls are done. We have a array of 8 elements. We call merge sort for sorting this. It has 8 elements. This function call, when we call merge sort, it calls 2 function call, as you see in the code. Here we have 2 function call, a function call for the first part and the second function call for the second part. The first function call also inside itself has 2 function calls for its 2 part. Okay, so one merge sort is called here on an array of 4 elements. When we call merge sort for the first 4 numbers, inside this function call, again, 2 function call is called, one for the first part and the second for the second part. So we call a merge sort. We have a merge sort on the first 2 elements. Again, for these 2 elements, inside the merge sort, we call again 2 function. We call merge sort twice, one for the first element and the second for the second element. So we have a function called merge sort on the first element. Okay. So from the top, we have a merge sort call on 8 elements. Then we have a merge sort on the first 4 elements. Then we have a merge sort for the first 2 elements, and then we have a merge sort on the first element. Okay. In this step, inside this merge sort, inside the last calling of merge sort, we have only an array of only 1 element. So we do not have further function calls and stop condition satisfied. So we return back. We return back to the parent. We return back to the function that has called this function. Okay. So if we are in merge sort, this merge sort returns, and we come back to the merge sort of the upper level. Okay, in the upper level, the first function call for the first part has been done. So it makes calls. It makes call for the second part. So a function call is done for the second part, which is also only one, which is also contains only 1 number. So we have a merge sort. We have a merge sort call here, merge sort. Again, this merge sort, because it has only 1 element, the stop condition satisfies, and it returns. It returns to its parent function. To merge sort in the upper level. Okay, in this merge sort, 2 function calls have been done, and we should call, we should do combining, we should call merge. So in this function, we call merge, and these two parts are merged. Then we should do nothing to do in this function call, and we should return back. So we return back to its parent. Okay. After merging, after we do merge, after we doing merge, we return back to its parent. By its parent, I mean the upper level function call. The upper function calls the lower function. Okay, so when we return from the lower function, we return back to the upper function. Okay, in the upper function, when we return from the first call, we should call the second. So merge sort is called for the second part, which is which has two elements. For these two elements, merge sort is called merge sort. This part has two elements, so it is further divides the array into two parts, and for each part calls itself again. So a merge sort is called for the first part. The first part of this array has only one element, so the stop condition satisfies, and we return back to its parent. Then it calls this function, the merge sort, for the second part. So merge sort is called here for the second part, which is only one element. So stop condition satisfies, and we return back to its parent. Okay, in the parent, two function calls have been done, and we should merge, and after merge we return back. So we merge them and return back to its parent. No, in the parent, both function calls have been returned. So the only thing that should be done is merging of these two parts. These two parts are merged, and we return back to its parent. So merge here is called, and we return back to its parent. In the parent, no, the function call for the first part has been done, and for the second part we should call the function call. We call the function for the second part. Second part has 4 elements. Again, because this is a recursive call, recursive function, it divides the given input into 2 parts. Any of them has 2 elements, and call the function call for the first part. It calls merge sort for the first part, which has 2 elements. Again, this 2 element is divided into 2 parts, and the function is called for the first element, which has only 1 number, merge sort. Here we only have 1 element, and the stop condition satisfies, so we return back to its parent. Then it goes for the second call and calls merge sort for the second part. Second part has only 1 element, and the stop condition satisfies, and it returns back. No, here we have 2 elements, and for each of element merge sort has been called. So we merge them and return back to its parent. So here merge is done and return back to its parent. In the parent, we have done the merge sort, we have done the calling of merge sort for the first part, and we should do it for the second part. So again, merge sort is called for the second part, and it has 2 elements, and then it is divided into 2, 1 element, and call merge sort and return back, then call the merge sort for the second part and return back. And when both function calls are finished, then merge them, and after merging, return back to its parent. In the parent, we have done the function call of the first and the second part. So the only thing that has been remained is merging these two parts. These two parts are merged, and we return back to its parent after merging. And in the parent, that is the toppest merge sort, or the first function call of the merge sort, the first part and the second part has been sorted, and the merge sort has been called for the second and the first part, and the only thing that is remained is merging these two parts. These two parts are merged, and the function returns, and the work is done, and we finish, and the merge sort is finished. Any question? This is the concept of recursive call. In many courses we see this concept in programming language, in basic programming language, in advanced programming language, and other courses. Okay. One of your friend asks how we do if the number of elements is odd. Okay, when the number of elements is odd, one part has less elements and the other part has more elements. For example, if we have 7 elements, the first part has 3 elements, the second part has 4 elements. Okay, so it is not required that the two parts have exactly the same elements, exactly the same number of elements. Any question? Okay, in this lecture, we talk about one of the methods for designing algorithms. I mean divide and conquer, and a famous approach, a famous method for designing algorithms. It has 3 steps. In the first step, it divides the problem into smaller problems. In the second step, it solves each sub-problem recursively. And in the third step, the solutions of the sub-problems are merged, are combined, and the solution of the original problem is computed. Yes, please. Border of an array should be fixed. When we define an array, the size of the array is fixed, and the number of and the maximum number of rooms of the array is fixed. As you see in programming languages, for example, in in C programming language, when we are going to define an array of integers, we write something like this, something like this. Int a, for example, 10. This is an array of integers. This array has only 10 rooms, and the first index is 0, and the last index is 9. So the size of array is fixed, and the indexes are fixed. I am not sure that if I answered your question. Yes. Yes, yes. Yes, let me explain. Yes, let me explain. Here when we here when we when we are going to merge these two parts, we use the value of infinity. In computer, we do not have infinity value. Okay, infinity. We do not have infinity value. So what I mean by infinity here? By infinity here, we mean the biggest number that we can define. Okay. For example, if we have integer values, we can put the maximum value that an integer can have as the infinity. So here I mean a very big number, a very big value here. Okay. Yes. Yes. We can put here the most largest integer instead of infinity here. Okay. Any question? The infinity values here help us when one of the parts reaches to its end. The numbers from the other part is copied to the destination, because when we reach to infinity, then the numbers in the other part will be the minimum and will be selected for copying to the destination. So these infinity values here help us to have a simple to have more simple algorithm. When we reach to infinity, then automatically the values of the other part will be copied to the destination. Any question? Yes, I told TA to select some exercises for you. Then I will send you the selected exercises. As you know, this time is the time of exams of the students here, and they are busy by exams. But I told TA to provide the list of selected exercises for you when it will be ready. I will send you. Okay, the lecture is finished here. If there is any question, I will answer the questions. If there is not any question, then we can finish the session and say في أمان الله.
في أمان الله.
خداحافظ شما.